quick overview of the motor and I put together for a phase converter. It's a, let's see, horse motor. Inside of here, I built this guard so my kids wouldn't put their hand in it. Now there's a treadmill motor. It's kind of rainy, so it's foggy, but you can see it's a treadmill motor. There's DC controls for it. I wired up a while back, and then I got a centrifugal switch. I ordered offline and pulled that switch itself out of a washing machine, but the switch that goes on the shaft there, I ordered it offline. It was like 25 bucks. I have my capacitor bank here. It's in a box in case it explodes. Capacitors are dangerous. They're not to be played with. And they can't explode even if they're in service. In a perfect application, they can't explode, so you have to put them in a box in case that happens. This right here, this switch turns on my small motor. And this switch here sends voltage through my large contact to engage it. But it has to be satisfied at the centrifugal switch first. So, since the centrifugal switch is not satisfied, this doesn't do anything. Okay. So, let's turn on my small motor. It gets up to speed. This dial here is for my small motor. That's a potentiometer. I dialed it in to the RPM according to the sound. That way when it does switch, there's not a huge jump. So to shut it down, see that small motor is not even in service anymore. When this engages the big relay, it also engages a smaller relay in the back of that box that disengages that motor. So if they're both on and I have a power failure, okay, then the power comes back on, it continues to go. But if I have a complete power failure so that it loses RPM completely, well, it loses rotation completely on the motor. Wait on it, slow down. Alright, see. Centrifugal switch is no longer satisfied. It'll crank up, get up to speed, and then turn back on all on its own. I don't have to come out here and reset power or nothing like that or chase it down. A quick look inside the box. Inside the box, there's my transfer switch. In the back, right about there with the white wire coming into it, that's my potentiometer. The other switch, you really can't see it there. It's way down in there in the back. It's got some lugs on it. You can see it. It's, let's see. It's got a green wire coming into it. See there? Then I got the transformer for my DC control for the treadmill. Then I got my large relay to pass single phase to my 3-phase motor to keep it spinning. And then a small relay back there in the back that disengages my large motor. Then from the bottom of the relay, I have my red wire there. That's coming from the motor. That's the leg being generated. And then I have my capacitor bank, which I have my common, hot, and hot. My capacitor bank runs down to that box for my capacitors. That's pretty much it. I'll get a copy of the wiring diagram real quick. Show it. There's my plug for 3-phase power. This here is the wiring diagram. You can see the note. I'm bad at spelling, but you get the idea. I built this to run my lathe. The reason I'm at 67 and 64 is because I don't have exact same capacitors. That's just as close to even as I could get, and pretty close to 240. You see my input is 238, and 235, and 234 is pretty close to it. So that's about as close to being balanced as I'll get it without overdoing it. But all this is the as-build. That's why everything's labeled like white, black, blue. This is what's in that box. This here's the aluminum heatsink you seen on the right from a DC control for my treadmill. That's the blue relay in the back. That's the large white relay in the front. My transfer switch is here. My centrifugal switch is here. My motor switch that's silver on the side of the box is part of this DC controller and the rectifier. The reason I killed power right here between the DC control and my motor is because that's the DC motor. I didn't want the coil passing those magnets and put a backfeed voltage into here after power's been shut off to it. Any questions? Just leave a comment.